Hey, it's your boy, Failing Chem Major over here. In today's video, we're going to be making some mayonnaise. Now, the main components of mayonnaise are going to be vinegar and oil. Now, normally you try to mix these two together, you're going to get this. The oil really doesn't like the vinegar, right? Reason being is the main component of vinegar is acetic acid and water, and both these molecules are extremely polar. The oxygen is very electronegative and causes a strong dipole to form, making these two molecules have some hydrogen bonds with each other. The oil, on the other hand, is going to be an unsaturated fat, and it's going to be extremely nonpolar. And what oil is mainly two components. There's a glycerol on the left-hand side, and connected to the glycerol are these long fatty chains. And since this is an unsaturated fat, there's going to be some double bonds. Unsaturated essentially means that it's not saturated completely with hydrogens, and again, due to the double bonds over here. These double bonds are also the reason why this is going to be a liquid at room temperature. This molecule can't really stack on top of each other as easily as if it was a saturated fat, which is why saturated fats are often butter. But since for mayonnaise we want to be able to mix these two together, we're going to be using oil. In this case, we're going to be using avocado oil. Now, the way since we do have to mix these two together somehow, the way we're going to do it is by using an emulsifier. And for mayonnaise, we're going to be using egg yolks. And the main component of egg yolks that we need to make this emulsifier are phospholipids. And in an egg yolk, 36% of the egg yolk is actually a phospholipid. And what phospholipids are they're very similar to the oil structure or the unsaturated fat we saw before, in the sense that there is a glycerol, and connected to the glycerol are fatty chains. But instead of 3 this time, there's going to be 2 fatty chains. And the other third part of the glycerol is going to be containing this phosphate group. And this phosphate group is extremely polar. And due to this polarity, it can form strong ion dipole bonds with other polar molecules like the acetic acid or water. The fatty chains, on the other hand, they're not very polar due to the reasons I said before. And I'm going to be representing this molecule as a structure over here, where the circle is going to be the phosphate-polar area of the molecule, and this squiggly line is going to be the fatty chain. When you add this to a solvent like acetic acid, or honestly anything like lemon juice, water, whatever you have, it's going to be forming this micelle. And this micelle essentially is due because the phosphate group on the right hand side is going to be forming the bonds, while the fatty chains are going to be hiding away and form the bonds rather closer to each other. And inside this structure, which is called a micelle, you can add our oil or fat because it's a nonpolar molecule, so it's going to be okay with forming the London dispersion forces with each other. Now, for mayonnaise, we can actually, instead of using acetic acid, vinegar, we can also use lemon juice. The main component is having this micelle filled with oil. We just need the acetic acid to form the micelle in the first place. We need some polar solvent. So now that we know what to do, let's go ahead and start making some mayonnaise. Alright, now let's begin our synthesis of mayonnaise. So first, there's going to have a tablespoon of vinegar. Like I said, the vinegar is not too important. We just need this as our polar solvent. We could also be using lemon juice or anything that's acidic. Next, we're going to be adding mustard. This also acts as an emulsifier and, tastes pretty good too. So, it's not open. Huh? Keep going. Okay, I'm gonna edit this part. Do you think I can? If I don't edit it, just here's some mayonnaise. Oh, that's gross. Okay, now let's go ahead and add our mayonnaise. We're just gonna add a little squeeze for flavor and to help our emulsifier. Now just add some salt for some seasoning. Right, our pepper, or not pepper, cayenne pepper, because mayonnaise is a bit too bland for me. That should be good. Now, our emulsifier. We're going to be forming these micelles first before we add any of the oil. Now, my trick for getting just the egg yolk out is by switching over this. I messed up. That's okay. We're going to try another egg. Now, my trick for getting the egg yolk out is by just moving it left and right over here. And we don't want the egg whites because that contains a bit too much water. I think that's around 80% water. We want mainly just the egg yolks. And for a cup of mayonnaise, I'm going to be adding 1 single egg yolk. Oop. Now, let's mix these together to form these micelles. Very yum. All right, now let's mix together. Let's go ahead. All right, so we're going to have to add the oil very slowly. My lab assistants are busy, so I'm going to have to try to do this myself And we want to mix this very, very fast. So if you have a blender or something, it's going to work much better, but I'm not rich, so I don't have that. So we're going to go ahead and mix this by hand as quickly as you can. Very, very slowly at first. Right? Very slowly. And I'm going to keep doing this for a while. Oops, maybe got too much there.
I assume we'll just speed through this part.
Yeah, I'll find a speeding program.
Video speed upper.
And just letting you know, or mayonnaise is mostly 65% oil. So we're gonna have to add a lot for a while. Whew.
Go.
Now that you're done with your synthesis of mayonnaise, your final product should something look creamy like this. The reason this is yellow is because I added that pepper because bland mayonnaise tastes horrible. So let's go ahead and give this a try.